Tilt-up, the basic principle behind tilt-up construction, constructing walls horizontally on the ground and then lifting them into place. Planning. The contractor is issued with an engineered drawing of the building. The contractor then designs a lifting drawing and see where the mobile crane would be placed in order to do the lifting of the columns and the wall panels. Casting of columns. All panels to be casted are indicated on the engineer's drawing with specific detail. Number 1. Casting. Excavation for the front columns. Pouring of the concrete to create a specific level to work from. Set out of concrete beds to pour columns and walls. Casted surface beds to start with the construction of the columns and walls. The surface beds are casted to the contractor's drawing and are numbered in accordance. Rebar steel. The steel rebar is placed on the casting surface bed. Formwork is done and lifting lugs installed depending on the size of the column. The lifting lugs are secured to the rebar inside of the column box. Lifting lugs are numbered to ensure the quality control, and lifting lugs brought in batches and sent for load testing. Lifting lug with 5.8 ton load test per lug. The red cap is removed after curing of concrete. Lifting lugs are secured. Base plate on top of column with holding bolts of the roof structure secure in place. Column box is ready for concrete. Pouring of concrete. The column blocks is ready for the concrete. The concrete is casted within the column box. The casted plastic cup in the columns are removed in order to expose the lifting lug. The lifting lug is casted in the columns. Conduit pipes was used to cast holes in the footing of the columns to secure the columns to the base. If the concrete sets, conduit pipes were removed to create holes in the footing of the columns. Holes in the footing that would be used to insert rebar rods to secure footing in the base of the column. Ready to be lifted. Base of the columns. The rib cage for the main dividing wall is prepared. Levels of mass concrete as per the engineer's drawing. The concrete sub-bases were poured next to the area where the columns would be erected. Base used to secure the columns in the upright positions. The exact positions of the column is marked on the concrete in the rib cage. 16mm holes are drilled into the center of the markings. 16mm holes are also drilled in the center of the columns. A piece of round bar is inserted in this hole when lifting the columns. This ensures that the columns are placed at their exact position. The columns are ready to be erected. The columns are secured to the sub-base structures at 100% upright position with column stiffeners. Columns are lifted with a special pulley system secured to a separate beam and mobile crane. They are secured by a red stiffener pole attached to the column and surface bed. Secured columns are in 100% upright position after the poles were secured to the concrete floor and columns. Left and right-handed threads are on the pole ends. Reinforced steel placed through the opening of the footing, secured with a steel rebar. Mass concrete is poured into the footing of the ribcage. Temp formwork is done around the lower securing points. After the concrete is cured, the securing points were removed and the openings were closed with the casting of concrete. Dividing wall. "36 columns are lifted in one day. Columns weigh between 40 and 44 tons. Columns are marked as per the engineer's drawing. Column has a A, B, C, and D side. The engineer drawings of the tilt-up panels. The drawings are also indicated in a grid line position where panels are to be placed. The drawings are available for every panel to be fitted at the exact location as per the engineer's drawing. Panel FW07H would be fitted on grid line A, crossing with grid line W and grid line X. Tilt-up panels indicating positions where to be placed and how to grab footing. canopy details and dock leveler details indicated on the engineer's drawing. Preparation to cast concrete beds in order to cast tilt-up columns and tilt-up panels as per set-out drawings of the contractor. Surface bed casted and polished smooth and levelled. Release bond were applied to the concrete slab and then again to the top panel after concrete is poured. Lifting lugs are casted within the columns and panels. The length of the lifting lug depends on the size of the panel or the column casted. Each lug is certified to lift up to 5.8 tons. Steel rebar and lifting lugs are placed as per the contractor's drawing and the engineer's detail. Concrete is casted. The next tilt-up panel is to be built on top of the existing tilt-up panel. Rebar is fitted to the tilt-up panel. Tilt-up panels are casted on top of each other as indicated on the contractor's drawing. Tilt-up panels weigh up to 50 tons. Panels are casted as per the engineer's drawing. The opening is filled with a solid and then covered with concrete. The piece will fall out as soon as the panel is lifted. Casting of a dock leveler wall, brace to prevent bending. The plastic cup that was casted within the lifting lug is being removed in order to secure the lifting equipment to the tilt-up panel. The area should be clear before the lifting process starts. Once the tilt-up panel is released from the bottom panel, the contractors start to remove pieces of concrete on the sides of the panel. Contractors remove pieces of concrete on all sides of the panels. Once the pieces of concrete has been removed, the contractors clear the area and the lifting begins. Spreader beam is attached to a pulley system attached to the panel itself. The panel weighs up to 50 tons, and there are 16 securing points which can handle up to 5.8 tons per point. That is 92.8 tons lifting capacity. This picture indicates how the pulley system pulls on all 16 lifting lugs and keeps the panels in place in an upright position. The panel installation. Note, prefix brackets mounted on columns. The panels are grouted as per the engineer once secured in place. The completed wall.